Okay guys, you should have the 10-3 notes for area of a sector. Please make sure your phones are put away and you are working diligently on the notes. You definitely need a calculator, and if you don't remember the area for circle equation, get out your cheat sheet for area and perimeter. So we're going to do the notes, and then you guys have a scavenger hunt activity, like an around the room activity. And then you'll get a homework page. You won't be able to do every problem on that homework page, but it will be due on Friday, and we will learn some more stuff on tomorrow that goes along with that homework page. So you guys will be able to find the area of a sector of a circle, find the measure of an arc, find the length of an arc, and find the measure of a central angle, which you guys have done. The measure of an arc, length of an arc, and the measure of a central angle. And now we're just doing finding the area of a sector of a circle today. Okay, so I'm going to let you guys do 1, 2, 3, 4, and 5. You should be able to do them. So pause the video here now and complete those. You're finding the area of each circle, and you are putting your answer in terms of pi and to the nearest tenth. So you should have 2 answers. Go ahead and pause and then complete those problems. So these are your answers. The radius for number 1 is 8. So you do pi times r squared. 8 squared is 64, so you'd have either 64 pi yards squared, or for the nearest tenth, you'd have 201.1 yards squared. Then for number 2, your diameter is 14. Go ahead, Nala. Your diameter is 14, so that means your radius is 7. 7 squared is 49, so you either have 49 pi yards squared, and then to the nearest tenth would be 153.9 yards squared. Oops. Hopefully you saw the last one because I'm not going back. The other answer was 121 pi yards squared, or 380.1 yards squared. Didn't know I could move the slides with my fingers like that. Okay, so go ahead and do these ones as well. You should remember how to do these from the previous notes. Number 4 is a semicircle. Number 5 is a quarter of a circle. So you'll need to do half the area for number 4 and a quarter of the area for number 5. So area of the shaded region, I'm going to do area of half a circle, which is 1/2 times pi r squared. This diameter here is 6 feet, so that means the radius is 3. 3 squared is 9, and 9 times 1/2 is 4.5. So it would be 4.5 pi feet squared, and this is in terms of pi. So we're going to leave the pi there in our answer. For number 5, it is 1/4 of a circle, or a quarter of a circle, so we're going to do 1/4 times pi times r squared. 4 squared is 16, and if I do 1/4 of 16, 16 divided by 4, that is 4, so I get 4 pi units squared. Okay, now on to the new steps. So an area of a sector is a fraction of the circle's area. So on those last slides, you just did half of the circle's area, and you did a quarter of the circle's area. So now we're going to be able to do even, smaller or bigger pieces of that and irregular pieces. So the formula is arc measure over 360 times pi r squared. So we're still using that area formula, just like we did the other day when we found the length of our sector. We use 2 pi r for circumference versus area. So for number 13, we have 45 degrees as our arc measure. So we're going to have 45 over 360 times pi r squared. So again, you can do like what we did the other day on Friday, and you can simplify and combine like terms if you want. So I would suggest doing the 18 squared first, which would be 324. And then that's going to be over 360. And remember, we can just tack that pi on at the end so that we don't really have to deal with it. So 45 times 324 over 360 ends up being 40.5 pi. And on this, it says leave your answers in terms of pi, but I changed it on the notes to nearest tenth. So we're going to write that. So 40.5 pi would be 127.2 yards squared. And that is the area of that little yellow piece. So then for number 14, we have this angle, you know, or you should remember, is 90 degrees. So I'm going to have 90 over 360 times pi r squared. My radius is 16 centimeters. So 16 squared is 256, and again I'm going to put that 256 with the 90, put the 360 on the bottom, and then you're just going to bring the pi down to get your final answer. 90 times 256 over 360 ends up being 64, and you bring that pi down, and then your final answer should be 201.1 centimeters squared. For 15, so it gives us this length, or this arc here is 120, which means that this would be 180 minus 120, which is 60 degrees. So this little yellow piece is 60 degrees. And again, remember, this is the same as this outside measure, and this is the same as this angle measure. So I have 60 degrees there, so I'm going to have 60 over 360 times 2, or not 2, pi r squared. We don't have our radius, we have a diameter, which is 26. Radius is half of that, so it's 13. So I'd have 60 over 360 times pi 13 squared. 13 squared is 169, so I'm going to have 60 times 169 over 360 pi. And your answer, well, 60 times 169 doesn't give me like a nice clean answer like it did the previous two. So I'm going to leave it as 101.40. So 10,140 over 360 pi. And then I'm going to put that in the calculator to get 88.5 meters squared. Okay, these next ones, they are asking for in terms of pi for sure. So you should be able to do this since I just did the first three for you and put my terms into the nearest tenth after finding the pi. But I'd like you to pause this and do these three on your own, and then you can come back and check your answers with me. So for number 16, the angle measure here, and you don't have to put A if you don't want to. The angle measure is 30, so 30 over 360 times pi r squared. 12 times 12 is 144, so I'm going to have 30 times 144 over 360 pi. And again, you just want to bring down that pi. So 30 times 144 and then divided by 360 is 12. You bring down your pi and then you make sure you put your units. So you have 12 pi inches squared. Yeah, it looks a little weird because you have that pi there, but you still need to make sure that you put your units. For number 17, you know that a circle adds up to 360. They give us this value of 90 right here. So in order to find the rest, we need to do 360 minus 90, which is 270. So that means this whole thing here is 270 degrees. So we're going to use that for our formula, 270 over 360 times pi r squared. The radius is 4. 4 squared, 4 times 4 is 16. And then we bring down that pi. 270 times 16 divided by 360 is 12. Bring down your pi and then make sure to write your units. So it's 12 pi feet squared. For 18, they give me the diameter, which is 16, so my radius has to be 8. They also just give me this little piece here. They don't give me the whole thing. So in order to find the whole thing, I need to do 360 minus 45, which is 315. So from here to here is 315 degrees. So formula, 315 over 360 times pi r, which is 8 squared. 8 squared is 64, so I'm going to have 315 times 64 over 360, and you're going to tack on your pi. 315 times 64 over 360 ends up being 56. Bring down your pi, and then make sure to put your units, which would be centimeters squared. Okay, now onto the back page. If you guys need to pause that and go back and look at the work, that's fine. Take your time. I know I'm kind of flying through this, but this should be easy for you to just plug in the numbers and get your answers. Okay, so working backwards, you guys know how to do this. This was on our previous test. Now, obviously, these ones are a little different because they have the pi there. So remember the area of a circle is pi r squared. So the circle has an area of 25 pi. We're looking for the radius. So I'm going to plug in 25 pi for my area, and then I'm going to have pi r squared. Nala. Then I want to get the r squared by itself. So I need to divide both sides by pi. And when I divide both sides by pi, the pi's end up canceling here, and they cancel here. So I have 25 equals r squared. And now that's something that you guys should remember how to do. So to get r squared by itself, I will need to take the square root of both sides, and I get r equals 5 inches. You guys go ahead and try the next one. Pause it if you need to. I thought I put that up there already. So set it up the same way and go ahead and solve for r. So you should have gotten 8 inches. The pi's cancel, and the square root of 64 is 8. So we are going to do these in the same kind of manner. So the area of a sector is your arc measure over 360 equals, or sorry, not equals, A equals arc measure over 360 times pi r squared. So a sector has a degree measure of 90 degrees at its central angle. The area of the sector is 16 pi inches squared. And we're looking for the radius. So we're going to have 16 pi equals, my arc measure is 90 over 360 times pi r squared. Now there's a couple of ways that you could do this. I would suggest you simplify this first, because most of the time that is going to simplify to smaller numbers. So 90 over 360 simplifies to 1 over 4. I'm just going to bring that pi r squared to the top of that fraction because pi r squared is like over 1. Okay, so in order to get rid of your fraction now, I need to multiply both sides by 4. The 4's would cancel here, and I'd just be left with pi r squared. And then 4 times 16 on this side is 64 pi. So now you're back to the problem like we did earlier for 1 and 2. So I would need to divide both sides by pi. The pi's cancel. And I have 64 equals r squared. So again, you're just going to take the square root of both sides, and you'd get 8 inches for your radius. So again, use the equation right here, and then try and set up the next one on your own. Pause it here and then try it. So the area of this sector is 10 pi. The central angle is 144. I'm going to put that over 360 and then multiply by pi r squared. So again, you can put this 144 over 360 in your calculator, and it is going to reduce to 2 over 5. And this pi r squared can go on the top with that 2. So then to get rid of the 5, the denominator, we want to multiply both sides by 5. So we get 50 pi equals 2 pi r squared. Okay, so we want to get the r squared by itself. We can divide both sides by 2 pi. On this side, they both cancel, so I'm just left with, and I'm going to go over here, r squared. Then on this side, 50 divided by 2 is 25. Pi divided by pi cancels. So now you can take the square root of both sides and you get r equals 5 inches. Okay. This one I want you guys to attempt to do yourself. You can easily find the area of the sector for AOC, and you can find the area of the sector for RPT. Okay, so the area of the sector for AOC, so I would have 45 over 360 times pi r squared, and that's an 8. So when you plug that in your calculator, you end up getting 8 pi meters squared. And then when you find the area of the sector for RPT, this whole half semicircle is worth 180. So you have 180 over 360 times pi r, and the r here is 4 because it's half of the diameter. And then this one would also end up being 8 pi m squared. Okay, so both the areas are 8 pi m squared. Sure, these pieces have the same area, but the sectors have the same area, so the sectors have the same area. But the circles do not. The circles cannot have the same area because one sector is only an eighth of the circle, while the other is half of the circle. So there is no way for the circles to have the same area because their sectors are not the same measure. Okay, I want you to try these on your own, pause the video, and try them. So Obviously, they have a match. If you cannot find the answer there, then you did something wrong. Go ahead and pause it, and then check your answers with mine. So the measure of arc AB is 90 degrees because AB matches, the arc AB matches your inside central angle. The diameter of circle Q, the radius is 4, which means the diameter is twice that, so it's 8, which is D. The length of ACB, so all the way from here to here, you can figure that out by doing 360 minus 90. And that will give you 270. So you would need to do 270 over 360 times 2 pi r to get your answer. Their circumference, you just use 2 pi r or pi d, whatever you want to do. 2 times pi times r would be 8 pi. The length of arc AB, you're going to need to use this kind of formula again, except that you know that from A to CB, or A to B, is 6 pi. So if that whole thing is 6 pi and the whole entire circle is 8 pi, that means that your length of arc AB is 2 pi. And then the length of a semicircle, so from here to here, would be 4 pi because it is half the circumference, which is 8 pi. Let me know if you guys have any questions. So our next activity, you guys are going to complete the around the room scavenger hunt. You can start with any station you want. You need to do the question on the bottom of the paper. Once you complete the question, you can then find your answer. So your answer will be on another sheet. And then once you find your answer, you complete the problem that is on the bottom of that paper, and so forth. There is an answer key up front, and you can check your answers. Obviously, the way that I completed it is in a different order, or might be in a different order. So as long as you start with that letter and then make that same pattern around, you have your answers correct. Once you finish the scavenger hunt, then you need to get the homework page and do the ones that you know. So like I said before, we are going to complete the rest of those notes tomorrow, and you will be able to complete that homework page tomorrow. All right, have a good day. Thanks.